given in this theorem. The equal chords of the circle are equidistant from the center of the circle. जो इक्वल कॉर्ड होती हैं वो सेंटर ऑफ सर्कल से इक्वल डिस्टेंस पर होती हैं. Just look what is given in the figure. Suppose this is center O. Okay, and these are the two equal chords, AB and CD. AB and CD. Is it there? What you are given? Circle. Center O, having two equal chords, AB and that is what you are given. AB equal to C, and we have to prove that they are equidistant from the center. Now, first tell me what is the distance of chord AD from the center of circle? This one. Suppose this is OM. Okay. And this ON is the distance of chord CD from the center O. ON is the distance, or you can say the perpendicular distance. In the word distance, the perpendicular is here. OM is the perpendicular distance of chord AB from the center of circle, and ON is the distance of chord CD from the center of circle. Is it there? OM and ON are the distances of the chords AB and CD respectively from the center of the circle O. Okay. What is the meaning of distance? Distance means that perpendicular distance. It means this is given 90 degree. This is given 90. Is it there? Or you are given what? OM is perpendicular to AB and ON perpendicular to CD. Is it there? OM is perpendicular to AB. This is AB. OM is perpendicular to AB and OM is perpendicular to CD. And there is a theorem, if perpendicular from the center bisect the chord. Therefore, AM will be equal to BM and CN will be equal to DN. BN, because perpendicular drawn from the center of circle bisect the chord. This is the theorem. Perpendicular from the center of a circle bisect the chord. Therefore, OM perpendicular AB, it will imply that AM and BM are equal, and OM perpendicular CD will imply that CN is equal to DN. Now just look one more thing. Since AB is given CD, this is given in the question. Therefore, half of AB will be equal to half of CD. Is it there? If AB is equal to CD, then half of AB will be equal to half of CD. Half of CD. Now tell me, half of AB means AM. AM is equal to BM is equal to CM and is equal to DN. Suppose this is equation number 1. This is equation number 1. All these things are given in this question. Now question is this: what we have to prove? These chords are equidistant from the center of circle. Now what we have to do? To prove what you have to prove, OM is equal to OM. Is it there? What you have to prove? OM is equal to OM. Now the construction work. The see these white lines. I am joining OA and OC. Join OA and OC. Is it there? OA and AC, we have to join. Now just look at the proof. Now you have two triangles, O and A and O and C. In triangle, just right here O and A and another triangle is O and C. O and C. Is it there? Just look the first thing. This OA is equal to this OC and this angle is 90. Angle OMA. Angle OMA is equal to angle O and C. This is 90 degree. And what's the reason? That is given. Another thing, OA is equal to OC. They are radii of same circle. OA is equal to OC, the radii of same circle. And AM is equal to CN. AM is equal to CN. Already proved it. Just look here. Here we have proof. AM is equal to CN. Just look here. AM is equal to CN. Already proved in equation number 1. Proved in equation number 1. Now just look here. Angle OMA, that is 90 degree. That means this is right angle. OA, side opposite to 90 degree. OC, side opposite to 90 degree. This is the hypotenuse. and this AM and CM, they are the sides. So by RHS rule, both the triangles are congruent. So by the RHS congruency rule, triangle OMA is congruent to triangle ONC, and when you will use this CBCT, what we will get? This OM is equal to OM, and this we have to prove. Just look here, what we have to prove? OM is equal to OM, or we can say equal chords of the circle are equidistant from the center of the circle. Now first look question number 4. What is written there? If a line intersects two concentric circles with centers O at A, B, C, D, then prove that AB is equal to CD. The figure is given there. Concentric circles having same centers but different radii. If a line intersects two concentric circles at the 4 points A, B, C, D, in this way, the figure is given here. Suppose this is the first circle, greater circle. One circle is this, and another circle is this. Both have the same center. These are the concentric circles. Concentric circle means circles having same center but different radii. There is a line. Suppose this is line L. This is line L. And this line L intersects these circles at point A, B, C and D. This line intersects A, B, C and D. Is it there? So you have to prove that AB is equal to CD. AB is equal to CD. Okay? This you have to do. Just see the construction more. See this construction. I have drawn this perpendicular. O N. Draw OM perpendicular line L. What this will say? If this OM perpendicular L, this will imply that the OM is also perpendicular to BC and OM is also perpendicular to AD. Is it there? If OM is perpendicular to the whole line L, then this OM will be perpendicular to this small part of line BC and the part of the line L, which is AC. This OM will perpendicular to BC and OM will perpendicular to this AC of AD. Is it clear? Now let's look at the proof. for the larger circle. For larger circle, what is there? This OM is perpendicular to AD. OM is perpendicular to AD. What will be here then? AM will be equal to DM. AM will be equal to DM. This is equation number 1. Because the perpendicular from the center bisects the chord. And the second one, for the smaller circle. For smaller circle, what will happen? This OM will be perpendicular to BC. OM will be perpendicular to BC, and then BM will be equal to CM. Then this BM will be equal to CM, and this is equation number 2. Reason is same because perpendicular from the center to the chord bisect the chord. Why AM is equal to DM and BM is equal to CM? Because the perpendicular drawn from the center of the circle to a chord bisects the chord. Now subtract equation second from first. Subtracting equation second from 1. What will you get? AM minus BM. What you will get? AM minus BM is equal to what? DM or minus CM. DM minus CM. This is M. Now just look here. AM minus BM. This is the whole AM or minus BM. What you will get? AB. You will get AB is equal to DM. DM minus CM. DM minus CM. This will be DM minus CM will be CD. AB is equal to CD. Jai Hind everybody. So today I am taking this problem from the topic circles. If two equal chords of the circle intersect within the circle, then prove that the first part, the line joining the points of intersection to the centers makes equal angles with the chords. And the second part is the segments of one chord are equal to corresponding segments of the other chord. This is the question. And what is this question? Now, just look at the diagram. This is the given circle. This is the given circle. We set the O. It has two equal chords intersecting at each other within the circle. Just look here. AB and CD. These are two equal chords of the circle intersecting at point N. At point N. Is it clear? What you are given? A circle with center O having two equal chords AB and CD intersecting each other at point N within the circle. And what you have to prove? You have to prove the line joining the point of intersection to the centers. Line joining the point of intersection, that is M, to the center of the circle. To the center of the circle. This one. This line. Which line? The line joining point of intersection to the center of circle. This makes equal angles with the chords. It means angle OMA is equal to angle OMD. What you have to prove? Angle OMA is equal to angle OMD. This you have to prove. And the second part, the segments of one chord are equal to the corresponding segments of the other chord. It means, just look at the segments of chord AB. Segment means part of chord AB, AM and BM. And this one, the segments of chord CD, they are CM and DM. What is the question? To prove that the segments of one chord are equal to the corresponding segments of the other chord. Meaning, the larger segments of one chord are equal to the larger segment of other chord, and the smaller segment of one chord is equal to the smaller segment of the other chord. So what we have to prove? Just look here. This means AM is equal to DM, and the second one BM is equal to CM. This you have to prove. What you have to prove? AM is equal to DM and BM is equal to CM. This is point C. This is point C. Now just look at the construction part. Just look here. This OM is here. OX is the perpendicular drawn. OX is drawn perpendicular to AB, and ON is perpendicular drawn to chord CD. Draw OX. This is the symbol of perpendicular to AB, and ON perpendicular to CD. OX perpendicular to AB and ON perpendicular to CD. Now just look at the proof. Since OX is perpendicular to AB, therefore AX will be equal to BX. AX will be equal to BX, and this ON is perpendicular to CN. Therefore, CN is equal to DN. CN is equal to DN, because there is a theorem. The perpendicular from the center of a circle to a chord, bisect the chord. Because this is the region. This is the region. The perpendicular drawn from the center of the circle to the chord bisects the chord. Therefore, AX will be equal to BX and ON perpendicular CD will imply that is CN is equal to DN. CN is equal to DN. Is it clear? Now, take these two triangles OMX and OMN. Now, in triangle OMX and OMN, triangle OMX and OMN. Just look there. The angle X is equal to the angle N. Which angle? Angle OXN. OXN is equal to angle ONN. Both are equal to 90 degrees. Okay, it is given. And this OM is common. OM is common for both the triangles. Is it there? And the third thing, this OX is equal to ON. OX is equal to ON. And what the reason? Because OX and ON are the distances of the chords AB and CD from the centers. And since AB and CD are the equal chords, therefore their distances from the center will be equal. So what is the reason for this? Equal chords are equidistant from the center of circle. Because equal chords are equidistant from the center of circle. So now just look here. This angle OXM and ONM, that is 90 degree, and 90 degree means R, right angle. Okay. OM is the side opposite to angle 90 degree, and the sides opposite to 90 degree is known as hypotenuse. So this is OM is hypotenuse. And OX and ON, they are the equal sides. This is S. So by way we will use the CPCD. First, just draw the two triangles. That is OMX. In this way you can write. This you can write down. O X and M. Is it there? What is the value of angle X? That is 90 degree. It means, and what is the 90 degree angle here? That is N. So this will be N. This will also 90 degree. Okay. Now this will be M and this will be O. Now this triangle and this triangle are in the CTCT positions. When two triangles are congruent, then their all the 6 parts are equal. How many parts does a triangle have? 6 parts. 3 sides and 3 angles. When 3 sides and 3 angles are taken together, they are known as the 6 parts or the 6 elements of the triangle. So just look here. What parts we have used here? The first part was OM. This we have to use first part. Another thing we have to use this OX and ON. This is the second part. And third part we have to use here. This 90 degree angle. So 3 parts we have used. 3 more parts will be equal. And what we require? Now by CPCT, just look here. Now angle, this angle, and which angle is here? Just at the side. O and X will be equal to what? O M N. Angle OMX will be equal to OMN. OMX means this whole angle OMA. OMA is equal to angle OMN. OMN means OMD. OMD. Is it there? And this is the proof of part. This here. OMA equal to OMD. Is it there? Now, for the proof of part second, we have this thing. This is, it is given AB is equal to CD. AB equal to CD is given. AB equal to CD is given. Therefore, their halves will also be equal. If AB is equal to CD, then half of AB will be equal to half of CD. Half of AB, that is AX, is equal to BX. AX is equal to BX and is equal to half of CD, that is CN is equal to DN. And this is suppose equation number. Is there any equation number? No. Suppose this is equation number 1. Equation number 1. Is it okay? Now what you are given? AB is equal to CD. Therefore, AX is equal to BX and CN is equal to DN. First thing is this. Also, since triangle, this one, OMX is congruent to triangle OMN. is equal to mn. You can declare this mx will be equal to what? Mn. This is equation number 7. Is it there? Now just look here. From equation first. From equation 1. And this is from equation 2. What is there? Ax is equal to, can we write? Ax is equal to, can we write this one? Dn. This one. These two parts. Ax is equal to dn. This is from first and from second mx. Mx is equal to mn. Mx is equal to m. Is it there? From equation first, what is there? Ax is equal to dn, and from second, mx is equal to mn. If we add them, ax plus mx and this dn plus mn. Now just add them. Adding it. What you will get? Just look at the left hand side. Ax plus mx is equal to dn plus mn. Now just see here. Ax plus mx. Ax plus mx. What is this whole name? Am. What is this? Is equal to dn plus mn. dn plus mn. This is what? dn. am is equal to dn. Is it clear? And this was the proof of this. Now last part we have to prove bm is equal to Cn. Bm is equal to Cn. Again from equation first. This Bx is equal to Cn or not? This Bx is equal to Cn or not? From equation first. Again from equation 1 and 2. And from equation 7. Just look here. Is it not here? Bx is equal to Cn. This is from equation 1. Bx is equal to Cn. Okay. And the second equation is mx equal to mn. Mn. Is it here? Bx. Okay. Is equal to Cn and mx is equal to Cn. Now subtract it. Subtracting. Subtracting. What you will get? Just look here. Bx minus mx. Bx minus mx is equal to Bx minus mx is equal to Cn minus mn. Cn minus mn. Now just look here. Bx by BN. What will you get? BN is equal to CN minus MN. CN minus MN. What you will get? That is CN. That is C